look at mission control. Of course, this is in Cabo at Kennedy Space Center. Kennedy Space Center is where the first satellite was launched on April 1st in 1960. So here we go with the latest technology being launched from the same place. We're hearing that all systems, as of now, are a go for countdown, so a little bit less than 6 minutes away. This is being launched on an Atlas V rocket. It stands 196 feet tall. We've got 4 rocket boosters, which will help to be launching the satellite into its official position. It's going to take about 3.5 hours to do that. So that's pretty quick by my standards when you think about it. And this is a geostationary satellite. So what that means is that it will move at the same speed as the rotation of the Earth. So we'll always cover the same area. And this is going to cover parts of the Pacific Northwest as well as into the Pacific Ocean. So we will benefit from that data just as soon as that is commissioned. So stay with us. We're going to continue to stay with it and carry the launch live for you right here on Storm Center on the Weather Channel. I'm meteorologist Jackie Jarrett. We've got meteorologist Chris Warren and meteorologist Kevin Wooten joining us as well as we have our big special hour here as the countdown to the Ghost T satellite launch is just about underway. We're just a few minutes away, guys.
It is pretty exciting stuff. A couple things worth noting here. We're waiting for the launch itself, which is, I think, a pretty cool thing. All right, just a lot of us think that's neat to watch, and it is. If you've ever seen it in person or even on TV, it's pretty darn cool. But also what it's launching, what the payload is. That is another weather satellite, which will eventually become GOES-18. And on top of that, guys, we're using GOES-16, essentially a sister satellite to help forecast the weather for this launch. Yeah, that's right. We've got one that goes east, one that goes west, and it brings us a clear picture, or as clear as possible picture as to what the weather is like here across the lower 48 and for the United States. This is something that's been ongoing for quite some time for NASA. And for NOAA as well. And it's really cool to see, by the way, that rocket, I forget the exact dimensions in terms of height, but that rocket, that Atlas V rocket that you see there now, just beyond the sun, was not there 24 or about 36 hours ago. In fact, they have to move it from the vehicle assembly building at a rate of, I believe, about 1 to 2 miles per hour. So it's quite the crawl for this thing to move because you've got all of the fuel and whatnot inside. So you don't want anything to slosh around or any sort of malfunctions as well in terms of wiring too. And this is something that has happened repeatedly. But of course, we're trying to replace GOES-17 now with GOES-T, which will ultimately become GOES-18 as well.
So we're getting in the window of about 3 minutes away from launch time. This satellite's going to do a lot of different things, too. When we think of satellites, oftentimes we think of just the clouds. When it comes to the weather, of course, we can bring you different variations to that. Like Chris was talking about the visible satellite. We can show you the water vapor imagery. We have infrared satellites. So there's all different kinds of channels. But we can also do things like detect wildfires. And that's one of the things that this new satellite is supposed to be doing very, very well, is detecting heat signatures. And in the time of climate change, when wildfires are becoming more common, when they're very ferocious, we've already seen that in this calendar year. Unfortunately, this is supposed to be able to detect and see some of the wildfires even before the human eye might be able to see them. So that's incredible when you think about that kind of technology. And it's not just wildfires. Of course, satellites change the way we forecast for hurricanes, and this will be even better for that. And so many of our storms too, Chris, by the way, a lot of them across the U.S., at least the lower 48, they start in the Pacific, and they go all the way across the country. So this will benefit everyone.
Jackie, you mentioned the first satellite going into orbit in the 60s. Yeah. And you hear us a lot, especially in hurricane season, talking about the satellite era and the importance, because we know there's been hurricanes, since there's been time, but it had to be observed by somebody, and it wasn't until satellites allowed us to see these storms, remotely from outer space on the satellite imagery to know that there was a storm happening. Because if there was no boat around or it didn't interact with land, then you never would have noticed. So that's why the hurricane season, the satellite era, is so important.
Yeah, this can also detect lightning, which can help us with severe weather forecasting. A lot of times we'll see big increases in lightning data when storms are becoming severe. So we're just a little bit over a minute to lunchtime. Let's just sort of dip in and see what this thing is.
1 minute. Rock, report range status.
Range green. All right, less than 1 minute away. You can see the blue skies. It appears that everything's moving along as it should.
Seconds. Stable at step 3. Verify ECS reduced for launch. Verify. 25. Status check. Go Atlas. Go Centaur. Go goes T.
About 10 seconds away. And there it goes. You see the launch of the Ghost T satellite aboard the Atlas V rocket.
Parameters look good. You have gone to close loop control.
And there it goes. You see the launch of the Ghost T satellite aboard the Atlas V rocket.
Parameters look good. You have gone to close loop control. The RD-180 is now throttling down as expected. Engine response looks good. We're now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
If you're wondering how
We
fast
have
this thing is
passed through-
moving, it's about 7,600 miles per
Vehicle is
hour.
now passing through Max Q, maximum
So it's
landing
Mach
pressure.
1.
Now, 55 seconds into flight, Atlas is 7 miles in altitude, 4 miles downrange distance, traveling at 1,900 miles per hour. RD-180 is now throttling back up. Now, at 75 seconds into flight, Atlas is 13 miles in altitude, 10 miles downrange distance, traveling at 2,700 miles per hour.
13 miles up already. On its way to 22,000 plus miles up.
Now, at 90 seconds into flight, ULA's Atlas V rocket weighs now just one half of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second.
Beautiful.
It is. There's the clouds from a camera's view.
Right.
The satellite's going to provide us similar information.
SOBs have burned out as expected, and we see a good SOB jettison. Vehicle now executing closed loop steering. Vehicle performance looks good at this time. Now 135 seconds into flight.
Everything operating as it should. The next generation of satellite being launched into space. Not only will this help us with weather information, by the way,
The RD-180 has throttled down
and
slightly.
space weather.
Vehicle performance continues to look good at this time. Tank pressures are stable, and Atlas booster battery voltages remain in their expected ranges. Now the upper stage is preparing for its use. Central reaction control system is now pressurizing flight levels.
Ghost T is the third of 4 satellites in the Ghost R series. This is going to help to extend our satellite usage and our plan, which will take us all the way through 2037. So this will serve us for years to come.
It's just over 1 minute until BECO. We're now seeing the RD-180 throttle limiting to to maintain a 2.5 G acceleration limit. Standing by for payload fairing jettison. And we've seen a successful payload fairing jettison. RE-180 is throttled back up now.
And by the way, we're looking at a live image from a rock
has reached the outer sea, 4.6 G acceleration limit, and will maintain this level through BECO.
Just incredible when you think about it. It was 13 miles up a few minutes ago.
We see
Probably
the
pushing
descent
double that in the amount of time that has passed up to this point. There you can even kind of see the curvature of the Earth from this angle now too. From that high, right?
I mean, we need to buy a ticket to go outer space, right?
You can watch it like
and
here.
BECO, booster engine cutoff. Standing by for state separation, and a successful state separation event. And we see pre-start on the R10. And mass 1, we have ignition for the first burn. This first burn of UAS Centaur upper stage will place the GOES-T spacecraft into a parking orbit around the Earth. This burn will last just over 7 minutes.
There's a great video on NASA, by the way, that helps explain this whole process. If you're interested in it, it fascinates you. Everything that you can see on the right hand of your screen and to the right, from there, from the white to the right, that's the satellite.
It was on the top of the rocket.
On the right hand side.
Yes, yes. But yeah, that's when it was vertical before it took off. It was that package on the top.
Upper stage systems look good at this time. Hydrogen line temperatures are approaching the bottle temperature as expected. The engine propellant utilization system has gone to closed loop control, and the engine response remains nominal. I just received word from the trajectory and performance group that booster performance was as expected from the booster phase of flight.
So with that separation, the vehicle now weighs a little more than 5% of what it did after its liftoff mass. So it loses all the fuel, it loses that portion of the rocket, and weighs 5% of what it did when it was sitting there at Kennedy.
Yeah, it's phenomenal to think. But how fast it went up, how much fuel has to be used to get up into outer space. So there's Earth on the left. And we talk about the geostationary element of it, because satellites operate in a lot of different ways. But this, essentially, just to recap, it's going to park itself over one part of the world. And in this case, when it goes to 18, it's going to be over a lot of the West Coast in the western United States. And it's going to move with the Earth. And the way I like to think about it is you think of like an imaginary anchor down to a point on the Earth, right? So
It's attached, but it's not attached.
it's not attached, but
tandem.
it's like it's moving with it on an imaginary anchor as the Earth rotates, so will the satellite. And that's how we can get the animations that we do with the clouds, whether it's the water vapor or the actual visible satellite,
Right.
or the infrared portion of the satellite as well, the satellite, the cloud images.
It's like making a movie. We take all those images and we put them together. And when we think about what's going on in the West in our country right now is we have a really serious weather event that's been unfolding for the last couple of days, that atmospheric river. And while we know a lot about atmospheric rivers, there's still more that we would like to learn about them and help improve our forecasting when it comes to the rainfall and the snowfall, as well as the amount and how long these things may end up ultimately lasting. And so this satellite will help us with data that we will put into our forecast to help better predict atmospheric rivers.
And also, Jackie, you mentioned the wildfires, which essentially, especially in California, around wildfire season now, and I'm just always amazed at the kind of data that satellites, even before this generation of satellites, was what they could do, but now the resolution that they provide is almost like high definition now.
Yes, that's part of the key of all of that. We'll have better imagery, which helps us to be able to refine the data that we have, right? You know, we used to think of it as being like a big chunk of air that we used to be able to get information out of, and that kind of leaves a little bit of a room to kind of not be able to get a lot of the details, right? And now that chunk keeps getting smaller and smaller and smaller, so we're able to fine tune the forecast with detail that we just haven't been able to do in years previous.
And the images, they come in much faster. You get them, you know, in minutes as opposed to chunks of minutes. In the past, you have to wait like 15 minutes or so to get a satellite imagery. And in the early days, you get like one snapshot, you know, for a big part of the day. But now you get down to the minute in the actual, because of that, you get so many more frames in a minute that you get a much better, more real time, which can also lead to better warnings as well as far as lead time.
Yes.
When it comes to severe weather, because you're not looking, and minutes matter, right? When we're talking about severe weather. So we're able now to, with these satellites, to have a much better idea in almost real time. Not quite real time yet, but almost.
Right, because storms build before the first raindrop ever falls.
Right.
So we can't rely solely on radar data, for example, to be able to detect severe weather as it develops. And satellite imagery is really critical for that because we can see perhaps an area. So often I think of Texas as one of the places where you'll see it happen so often. You what looks like clear skies, and all of a sudden you see these little puffy white things that begin to develop, and you know that rising motion is taking place in the atmosphere. We're going to be breaking through the cap and watching satellite imagery first as severe weather starts developing and ultimately can explode.
And one of the other things that we can get to coming along with this launch of GOES-T, ultimately GOES-18, is also the lightning imagery too, and not just seeing the lightning cloud, the ground lightning, but more intra-cloud lightning, which gives us a better indicator as some of the stronger storms that perhaps may be developing, and ultimately give us a better lead time too for severe thunderstorm warning. So there are a lot of new gizmos and gadgets on this latest rocket launch. If we need the next one, that would be GOES-U. And that would launch in April, I believe, of 2024. I was just checking out social media, by the way. You're seeing this launch moments ago. You can see that liquid oxygen and liquid hydrogen fuel that's burning off and creating this cloud. Anytime there's a launch, one of the cool things that you see, at least if it's clear outside, ultimately, is that sort of crescent as that rocket reaches orbit or goes towards its orbit. And so now images are starting to pour in as well. And the hashtag #ReadyToGOES, ready, TOGOES, is starting to take off on social media, just like our next satellite.
Certainly is. We're about to, 10, 11 minutes now into the flight, and everything continues to operate as expected on its way to get about 20,000 plus miles above the Earth's surface.
It really is phenomenal to see just this happening moments ago as we were watching it live here on the Weather Channel. That something that is so important for what we do. It's bringing up another satellite into space, and when it's operational, so much high-quality data, which eventually will lead to better forecasts, both long-term, because a lot of the data, of course, is used for the weather models. And Jack did an awesome job talking about how just knowing in severe weather season how little clouds, where are the clouds first, which ones are getting bigger, even before the first raindrop falls. The importance of collecting data cannot be overstated, I think.
Especially in a changing climate, right? We continue to warm. We're expected to continue to warm, and that can affect weather patterns all across the globe. What happens in other parts of the world impacts what happens in the U.S. as well. The atmosphere behaves like a fluid in kind of the same way that the ocean does. And so I think this is going to help us in the future, too, to help better forecast a changing world and a changing weather and a changing climate.
And this is almost like taking a really expensive cell phone or camera, holding it high into the sky about 22,000 miles above the Earth's surface and giving us a clear picture as to what we are seeing down on
forecast or even looking up a satellite, you can access so much of the information that we use on a daily basis just by doing a little Google search and looking at satellites. And there are a lot of resources available to you if you're interested to try and check some of those out. Check out what the infrared looks like versus the visible satellites. And all of a sudden the visible satellite data goes away and you're like, where did that go? Well, it's because the sun went down, right?
Right. Another thing too, we're talking about the availability of weather data, and not every country in the world gives out weather data for free.
Right.
The United States does. You can go on. You mentioned NASA's great imagery, so our government it is in many cases unique in that sense that that information is free. You can go on the internet and look at the National Weather Service computer models. You can look at the data that they use, and so this is just another one and a big one of the tools in the toolbox for us.
Yeah, they are our partners for sure. We could not do our jobs the way we do our jobs without our government and these satellites that are put up there. And one of the many reasons why weather forecasts have improved so much, even just in the last 10 years, when you think about how things have changed over the years from the 1960s when this all got started to the data and the resolution of all that we're seeing today.
And this group of satellites, when this came online, and it wasn't that long ago, it made a dramatic difference in what we show you, especially during severe weather season and hurricane season, when some of the detail is unmatched to what we had, as Jackie was saying, just a little bit more than a decade ago.
Yeah, it's March 1st, by the way. When we think about it, I don't think that was a mistake or a coincidence, right? This is the first day of meteorological spring. It's the time of the year when our weather begins to change, when we have the clash of the seasons. Severe weather starts to go up more frequently in March, April, and of course in the month of May. We're going to leave you with another look of the launch pad, and there you can see the Atlas V rocket launching Ghost-T satellites into space, all systems operating as they should. We're about 15 minutes now or so past the launch as this continues to move up to 22,000 miles above the Earth.